All right, students, so what I'm going to be looking at here today is inequality symbols. There's a couple of things I want to start off with is just talking about what we use inequality symbols for, and a couple of areas. One area, of course, would be in computer programming. It's a real big deal. Uh, any computer language pretty much has inequality symbols in it. That's a real important part of the logic of a computer program. I want to give you just kind of an illustration of this. In computer languages, we have if-then statements. So a lot of times we say, if I'm going to say G is greater than 90, right, like that, then let's say that the computer is going to print that you get an A. Okay, that's kind of what we call a pseudocode. And it's got an inequality in it. So G is a variable, so that G could change as you input it. So right now, if G was 91, since it's true that 91 is greater than 90, then it would go print A. If it's false, then it usually just goes to the next line of the code. So let's say the next line of the code was just print no A, okay, like that. All right, just to keep it kind of simple. So what would happen here if G was equal to 90, because it's not true that 90 is greater than 90, then you wouldn't get an A, okay, you get no A, right? So it just kind of shows you that computers know when a number's bigger or smaller than another number or when they're equal, all right? So it's used a lot in computer code. So that's kind of worth knowing as applications. A couple of things on this you want to look at is the symbols. You want to know the difference between less than, greater than, less than or equal to, and greater than or equal, and what they all mean. Okay, so kind of goes like this. Less than, a true statement would be something like 2 is less than 3. That's a true statement. All right. That would be true, but if you had something like 3 is less than 3, that's false. So you need to know the less than symbol and what it means. And what this basically means is the order the small number goes there, the big number goes there in order for that to be true. Greater than is just backwards. So you could have something like 5 is greater than 3. In this case, the big number goes there and the small number goes there. That would be an example of something that's true. Something that would be false would be something like 5 is greater than 6 or 5 is greater than 5. Those are both false statements that you have there. Okay, then the way less than or equal to works is like this. So you could have 7 less than or equal to 8. That's true. But also if you had 7 is less than or equal to 7, that's also true. So it can be true either way. And of course, if you had something like 8 is less than or equal to 7, that's false. So in this case, again, the big number is supposed to go there, and the small number is supposed to go there. So you just need to know the difference between the various symbols. This one is greater than or equal to. So for instance, you could have 8 greater than or equal to 7 is true. Or you could even have 8 is greater than or equal to 8 is true. Come in if you need to.
Oh, I didn't know what you would do.
Yeah, hold on. I'm just doing a video. Hold on, students.
Lisa.
Okay, sorry for the interruption. All right, so that's kind of how your symbols work. Now I'm going to go down the next page, and I'll show you how this works then. So I'm going to go through and have you work these out yourself. So I'm going to have you just pause the video and let you see how many of these things you know are true or false, okay? And then as soon as you're ready, just resume, and then you can check your answer. Okay, so this is what I came up with, and I'm going to go through each one of these. First thing I'm going to do is just kind of go through this column here and make sure that you understand that. One way to kind of look at this now is a lot of teachers teach this way. Go back to the old video game Pac-Man. Back when I was a teenager, Pac-Man had come out. It's a pretty old video game. So it's kind of like Pac-Man eats the big number and goes away from the smaller number. So no matter how you orient that symbol, the big is going to be what it's opening to. So that's kind of a simple way to look at that if you want to. You can make this into Miss Pac-Man. Actually, I was out to dinner last night and kids were playing Miss Pac-Man, another old video game. And it basically just had eyelashes and it had lips on it, if I remember right. All right, so that's one way to look at that. So really the thing that I always look at is the big number, make sure it's opening towards a bigger number. So in this case, 15 greater than 13, it's opening towards the bigger number, so it's true. This one's also true because they're equal to. However, if you had 17 less than 17, if you had that, that would be false. So that's how the equal sign works. This one's also true for the same reason. They're equal. And then one thing that you may want to know on this, sometimes students forget stuff like this. This is 2.78. Whenever you have a decimal, you can put as many zeros past that decimal place, the last digit, if you want to. So if I put that there, then it's pretty easy to see that 78 is bigger than 70. So again, it's opening towards the bigger number. Just try to think of it as opening towards the bigger number. And if it is, it's got to be true. All right. Okay, this one sometimes students struggle a little bit with. You got to think about how a number line works. So actually, on a number line, you would have this. The bigger number actually is the -3, and the smaller number is this. So it's not opening towards the big number, therefore it's false. This would have to say -3 greater than -5 in order for that to be true. Negative numbers are kind of backwards. They're mirror images of how positive numbers are. This one's false because they're not equal. The numbers are not equal. It's got to have the equal sign to make that true on it. This one's true because it is opening towards the bigger number. And this one, again, kind of works like this. On a number line, it would go, here's 0, -1, -2, -3, -4. So it goes like this. This number, -2.35, is like there. And then the other number is there. So the bigger number actually is the -2.35. So one kind of quick way to do this is, just look at the bigger number. What I'm doing is just highlighting the bigger number on each one of these, and you're just seeing if it opens towards the bigger number. You can think of the Pac-Man thing if that helps you to remember that. Okay. All right, so that'll take care of that. Now, next thing we're going to look at is interval notation, graphing, number line graphs. Now, I made up some examples because I'm going to have you do some of these and make sure you got this together. This is sort of a summary of all the possibilities. This is the inequality notation. We're going to learn how to do interval notation and then how to graph on a number line. So you can just pay attention to these examples if you want to, or you can write them down on scratch paper. It's totally up to you. So whenever you have x in the middle of two numbers, that's exactly what it means, is it means it's between like -1 and 3. So a couple of things that you learn on here is if you have a less than or equal to, you're going to shade to the left, and you're going to use a bracket, and that bracket, what that does is that includes the endpoint. Okay, if you had a less than, then you're still shading to the left. You have a parenthesis, so that excludes the endpoint. So every symbol has a meaning to it. If you have greater than or equal to, you shade to the right, you use a bracket, and again, that bracket is including that endpoint as a solution to that inequality. If you had greater than, it's to the right, it's a parenthesis, so it excludes. So that's kind of how you put all this together. So what you would have on this example, -1 less than or equal to x less than or equal to 3, you're including both of those endpoints right there. So really all you got to do is just locate 0 locate 3, locate -1. I'm going to zoom on this so I can see this a little better. And then just do this. Okay, you're going to have a bracket on -1 to include it, a bracket on 3, and then you shade in the middle. So when the mathematical meaning of this is it's every number that's between -1 and 3, but the endpoints are also included because of that equality on there. That's what makes that happen. And that would be all those decimals, fractions. There's actually an infinite number of numbers in between any two numbers on the number line because you've got all the decimals, fraction, there's an infinite number of those. Okay, the next ones are going to be very similar. I'm going to just say here's 0, here's 3, here's -1. Now what's going to happen on this one is included. So what you want to do is use your bracket there to include that. Okay, then this one is excluded. So you're going to use a parenthesis on the 3 to exclude that. And then you shade in the middle like that. So when you see that, you need to understand that this is just a symbolic meaning, a pictorial graph of solutions. It's every number between -1 and 3 that includes -1, but it doesn't include 3. So 3 is not a solution, but -1 is. Okay, that's what that means. Then the rest of these are pretty similar. So I'm going to do the same thing here. Here's 0, here's 3, here's -1. So I'll do this. This one is going to exclude. So you exclude the -1. That's got an equal to, so you're going to include the 3 with a bracket, then the shade in the middle. Okay? And then the next one, think about what this would be. Again, I'm going to locate 0 somewhere. 3, doesn't matter where you locate that. That's going to be excluding both of those. So they both get excluded from the solution. So your graph would go parenthesis on -1, parenthesis on 3, and then shade in the middle. So those are actually all the possibilities there are. And you always use less than symbols because you're ordering this from left to right. When you write this, you always want this to look kind of like this. The small number there, and then the bigger number there. And we always use less than symbols when we're writing this, okay? If you did greater than symbols, then you would have to write this like this. It would be true if you did it this way, all right? But this is the most common way, is to write that like that. Okay, now I'm going to move down, and now these are just one-way graphs. So this is less than or equal to 3. So again, you locate where 3 is. Okay, you're going to shade to the left. All the numbers less than 3 are to the left of it. You include 3, so you put a bracket. Then you just shade to the left like that. That's all you do. Now we'll go back and do the interval notation on this stuff in just a minute here. Okay, I'm going to do the interval notation after I do the graphing. All right, so the next thing I'm going to look at is this is x less than 3. So again, what we'll do is we have 0, 1, 2, 3. We're going to put a parenthesis on that, and then we shade to the left. So less than is always shaded to the left. That's the difference, again, between bracket and parentheses. That includes the endpoint if there's an equal to bar, and you exclude that if there's not. Okay, so it's real simple. Okay, the next two are greater than problems, so they go like this. Here's 0, here's 3. All right, what you're going to do is put a bracket there, and you're going to shade to the right. Okay, greater than means go that way. Okay, and then this one, same way. Find 3. Greater than means to the right, but you exclude, so you put a parenthesis, and it goes like that down. So that's how your graphs go. And then the next thing I'm going to do is just show you the interval notation on these things and on these 8 cases. So I'm going to scroll back up here, and then we're going to write the interval notation. So the interval notation is just like the graph. On this, it starts at -1, comma, ends at 3. So when you do interval notation, you're ordering it in left to right. This is the beginning, that's the end. Left to right, it's always that way. So it's just like it is on the number line. Same thing here. This one starts at -1, includes it, so the bracket, comma 3, exclude the 3, goes like that. Okay, this one, same idea, starts at -1, but excludes it, ends at 3, includes it, like that. Then this one's 2 parentheses, so it's going to exclude both. Okay, so when you're learning this, you want to understand how the interval notation goes, because that's the most common way to write your answers, right? These 4 problems here have a start and a finish, okay? The rest of these have infinity in it, so these go like this. If you go to this situation, it'll go like this. You have a comma. Now this one starts infinitely to the left, so we do negative infinity, then we do 3. Okay, anytime you have a less than, the infinity's on the left. So you put a bracket there to include it, but you don't put a bracket there. You never put a bracket on infinity, because infinity is not really an endpoint. It's a concept, just means it goes on forever. So you don't include infinity. It doesn't make any sense to do that. Okay, the next one will go like this, same idea. It goes negative infinity to 3, only difference being you exclude the 3, and you always have a parenthesis on infinity. Okay, the next 2 go like this. This one starts at 3, it goes to the right, so the infinity's on the right. You include 3, you never include infinity. Okay, this one, same idea, starts at 3, goes to infinity, don't include the 3, and never include infinity. Okay, so see, that's how that goes. Now, a couple of things that'll help you sort this out in your mind. See, on this, if you go to the left, then infinity's on the left. If you go to the right, then infinity's on the right. So it's real easy to remember that. Okay? All right, so what I'm going to have you do, you can pause if you need to think about this a little bit, but I'm going to have you pause the video and do these examples. A should be B, C, D, E, and F, and then the video is going to stop there, then we'll go over those. So go ahead, and it's a good idea to stop now and see if you are processing this okay. Okay, so you can go ahead and check your answers. The first one is x is greater than -2, so you should shade to the right. You should have a parenthesis on -2, meaning you exclude the -2. And then your interval notation is -2 comma infinity. Again, if you shade to the right, infinity's to the right. Okay, the next one, you should have located 4, shaded to the left. With parenthesis, you're excluding, okay? And again, with this thing, the idea is shade to the left, infinity's on the left, shade to the right, infinity's to the right. Okay, that's an easy way to think of that. Okay, the next 2, you should have this. They have the equal to bar now, so you're going to be including anytime you see the equal to bar. So you locate 0, go to the right, since it's greater than, shade to the right, and then infinity's on the right. So again, anytime you shade to the right, infinity's on the right. Okay, this is a less than or equal to, so you're shading to the left. Therefore, the negative infinity's on the left. So that's how your solution to that problem should have went. Okay, and then the last 2 are the ones that are in between. So this is shade in between -2 and 3. Have a bracket to include -2 because of the equal to sign. And then exclude the 3 because it doesn't have an equal to sign. And then your interval notation, just like the number line, bracket -2, comma, ends at 3. Start, finish. Okay, same idea here. -5 to 6, they don't have equal to signs. That's why I use parentheses, excluding both endpoints. And then the interval notation is -5 to 6. Okay, so one thing that you want to be able to do is when you see interval notation, you want to immediately know what it means. So like this one would mean all numbers between -2 and 3. -2 is a solution, 3 is not a solution. This one means all the numbers on a number line between -5 and 6. Remember, that's all the decimals and fractions. There's an infinite number of numbers between any 2 numbers on the number line, but they're excluded. So -5 and 6 are not solutions, okay? All right, so that'll wrap that up, and you want to get that down because the next topic, well, you'll be required to know how to do this interval notation. All right, best of luck.